Hi there, and welcome back to the Energy Sector Heroes podcast. My name is Michelle Fraser, and every week I will speak with incredible people who share their lessons, experiences, and stories from their time spent in the energy sector. Hi there, and welcome back again to this week's episode. If you're new to the show, then please take a second to subscribe and even consider sharing the show with just one other person. This week I am joined by Alastair Boyd. Alastair has over 30 years experience covering energy, engineering, operations and project management. Alastair, would you like to introduce yourself, please?
Good evening, Michelle. Nice to meet you again. Yes, I'm Alastair Boyd, and we work together at Enquest.
So, Alastair, how did you get started in the energy sector?
It was probably more by luck than anything else. I like sciences at school. I did engineering degree, process engineering. Fortunate enough to be sponsored through university by the MOD in the nuclear industry. And when I graduated, I decided didn't want to do that. I eventually moved up to Scotland, started working in the downstream chemical system. Worked there for a couple of years, then the opportunity arose to move into the oil industry and move up to Aberdeen in 2003, it would have been. I moved up and I've been here ever since.
So did you find it easy to transition between the nuclear and the oil industry at the time?
Well, nuclear was just when I was a student, and then I went into the sort of the chemicals. So chemicals and oil and gas wasn't massively different because process engineering in terms of designs, running small projects, what you need to do, a lot of the skills are quite complementary. It's not a massive difference between the two of them: line sizing, relief valve sizing, control valves, operability, operation support. They're all quite similar.
So what made you go into process engineering?
As I say, it was probably more luck than judgment. Going back to when time at school, my best subjects were maths and chemistry. And when I decided to apply for university, I was looking at different courses, and there was one chemical engineering, which I landed on, something I'd never heard of before, but it looked quite good. I was not unsure as to which way I wanted my career to go. And it seemed to be quite a wide-ranging degree, and that it didn't lock you down into one specific area at the time. So that was probably the reason why I chose it. So it's probably been fairly systematic for most of my career that I've tended to make decisions based on things that pop up at the time, as opposed to having any clear career path mapped out and religiously trying to follow it.
Okay, so have you never really mapped out your career?
No.
It's just been by luck?
Yeah, about that. Yeah, when I moved up to Aberdeen, I worked for a process consultancy. I stayed with them for just over 10 years. I was seconded into one of the oil companies. As part of that, they eventually offered me a job with them. I transitioned across, stayed with them. Then they got taken over by another oil company. So I stayed with them for 7 or 8 years. Got a bit disillusioned working with them. Some of my colleagues had left and gone to Enquest. They then phoned me up and asked me would I like to come and join them for one of the projects they were doing. And so I decided to jump and go with them, and been with Enquest now for nearly 12 years. So I've not been one that said in 2 years' time I'm going to do this, in 3 years' time I'm going to do that. I've very much just sort of gone with the flow, see what happened, and if opportunities arise and look good, I would take them.
Okay, but do you think it's important to just take opportunity, to jump on every opportunity that you're...
It probably depends on what your personality's like, what you like doing and what you don't like doing. So it's, some people are very focused on where they want to go, what they want to do. I tried to, in my early years, get a reasonable grounding in different types of engineering. So I've done front-end study work, I've done operation support work, I've done the detailed design, startup commissioning. So I've pretty much seen things through from pre-concept stage all the way through to startup, and then shutting down and getting rid of them. So it's I think for a lot of people they can tend to get pigeonholed early in their career, which is not something I've been fortunate enough I didn't actually do. And I think with if you are making decisions and moving, It's you need to think about some aspects to it in terms of your employability, your network, your range of skills. Financial things obviously important, but certainly some of the younger engineers do seem to chase the money very, very quickly, get themselves pigeonholed in one specific area, and then if the market changes, there's any downturns and things like that, they may find it difficult to stay in employment.
So, do you think it's better for the younger engineers to get a broader range of experience rather than
Yes, very much so. And that wouldn't just apply to engineering. That would apply for me. That would apply to anything. I've worked for consultancies. I've worked for operators. So I've worked sort of both sides of the fence, and the issues that you have depending who you're working for and what you need to do can be quite different. So when you've got the view, when you actually see it from both sides, it's much easier to be more rounded, making the right decisions, and actually working collaboratively with people to try and get the best results and outcomes for everybody.
Okay, that's really good advice. So you've had an amazing career actually, where you've worked, where you mentioned before that you've worked in various different phases of the
Yeah.
project. What phase do you prefer working in?
Um, I quite like the hands-on stuff. So if I've been fortunate enough to be involved in probably four, five, six startups. And so early on in my career, there was an FPU, floating production unit, which is Carnegie Janus facility. I was a startup engineer on that. So I worked in the design. So that was probably a year on that, and then a year or two offshore, getting it started up and getting it stabilized. And then there was a Carnegie had another asset, Griffin. They started up a couple of subsea tiebacks, Tulloch and McClure, was involved in those. Then on Janus, we had there was a couple of wells we tied back to it. There was the Affleck project, which was going up and over it. There was Leiden, that was another startup. Captain Area B, Hess on Triton, then Kraken. So I quite like being offshore. It's easy because you don't have to think about anything apart from work. You fall out of bed, put your shoes on, go downstairs, get your breakfast, and you're there. You don't have to worry about commuting in, doing the shopping afterwards, doing your washing or your ironing or what you're going to do. It's intensive. You're working long hours, a lot of pressure on you, but you're able just to focus on what you're doing. So yeah, it's probably the actual hands-on, say whether it's offshore in the shipyard or something like that. Actually seeing the equipment that's been designed, working with the operations team, coaching them, training them how to run it and operate it, and getting it online, and then getting it all stabilized and handed over is good.
So do you think it's important for the younger engineers to go on site or offshore?
Massively. It's very easy looking at an ID or a drawing to think the size of something, but if you've worked on an asset where you've got a £1,500 or £2,500 system, big heavy, valves, lines might be 12, 16, 18 inches, and it doesn't look very big in the P&ID. When you actually go and stand beside it, the actuators in these things could be 2-3 meters long. And if they're manual valves, if you don't have a hydraulics to open them or something like that, you try and open one of those manually. It's unless you're a bodybuilder, it's not something you're going to do very, very quickly. So for a lot of the younger engineers to actually understand the size and the complexity and how everything sort of fits together, access to it, some of the human factor issues you need to think about. If you've only ever worked on the design, you might be a fantastic designer, but what's on paper versus how it works in reality can be very, very different.
I agree as well, actually, because I've been on site quite a lot. It teaches you how to troubleshoot as well quite quickly.
Yes. And it's a lot of the operations people that have been there for years, they might understand some of the theory behind stuff, but they'll be very, very well able to tell you what works well, what doesn't work well. And if you put a valve in the wrong place, or you got a branch coming off somewhere that doesn't need to be, it can cause chaos. It's, as I say, a lot of the times if you've got 2 or 3 isolation valves in a system, if they're spaced apart, I've worked on assets where you might have one valve in one module, another one 2 flights of stairs up higher, you can't see the two of them, and trying to coordinate stuff and manage it becomes well nigh impossible, where you could have put them right beside each other, and the whole access piece would have been so much easier.
Okay. So, as a process engineer, you have a lot of responsibility because as a process engineer, you would be responsible for designing the whole plant. That is quite a big, huge responsibility to be on anybody. I know that there's usually a team of you, but it's still quite a huge responsibility.
Yeah, I mean, on the Kraken project, the FPSO was the engineering manager for EnQuest, managing the third party company Boomi that were designing the FPSO. So I mean, technically, you need to know enough to know basically when people are bluffing you. You don't necessarily need to know all the answers, but a lot of times it's being able to ask the right questions and just making sure that the answers you're getting back are credible. Nobody knows everything. Nobody can possibly be considered to know everything. So it's very much about how you manage your team, and making sure you've got the right people in there that have got the right technical expertise. So even though I'm a process engineer by background, we're working at the moment with the process TAs, the technical authorities. I can ask them questions as to why they made the conclusions. Is it right? Is it wrong? And the same with some of the other disciplines. But ultimately, that they're the ones that make the final decisions, and they're the ones that have got much more in-depth knowledge than I would have on their specifics. So it's oil industry is massively big teamwork. It's how you work together, and you need to be able to trust your team, and you need to be able to have confidence that the team's got the correct technical competencies that you need.
So, how do you make sure that you've hired the right people?
Combination of things. I mean, amount of experience will be one. Making sure they've got the right qualifications, certifications. So, if you're a process engineer, you should be a member of the Institute of Chemical Engineers. Electrical engineers, Institute of Electrical Engineers, etc., etc. You would, interview them, discuss things with them, take soundings from potentially other colleagues that might have worked with them, might have known them. You might trial them out with some tests and things like that. There's two aspects to it. There's one is the technical side, and the other side is the people. It's pointless employing people that are the most intelligent ones there if they're not able to communicate and get other people to do what they're wanting. And whether it's somebody that's overly quiet or somebody that's overly loud, it doesn't really matter what their personality actually is. They need to be able to fit and work well in a team. And it's probably some of the projects that you do, it's no different to some of the best sports teams, where the manager at the end of the day is bringing together, it's football, 11 players on the pitch, rugby, 15 players on the pitch, and it's how do you mold the team. So you might necessarily have the best individual players, but it's getting the team that will work together. People don't have to like each other, and they do need to respect each other, and they need to be able to work with each other. So anywhere I've worked where you've had successful teams, it's you've got that combination of people that have gelled and have worked and delivered. Sometimes it's probably more luck as opposed to anything else, but sometimes you do find that these teams tend to sort of work together, remold themselves. You get a couple of casualties along the way. You bring a couple of new people in, but ultimately the successful teams will work well together. And you quite often find that certainly on the project side of things, you'll get the same team that go from one project to the next project because they all can trust each other to deliver what they need to do.
Okay, but building trust within a team must be quite challenging.
Yes, it is. I mean, there's plenty of training sessions you can go to, like your icebreaker sessions, get to know everybody, where you do all these game things and have fun and things like that. Sometimes they work, sometimes they don't. Some people love those sort of things, other people don't. I tend to be a little bit more introverted, so a lot of these things it's a wee bit outside my comfort zone. But it's as I say, a lot of the times it's when you're working within a company, you've got some flexibility in terms of the team makeup you've got. Other times it's I would say to a certain extent it's the people that's free and available at the time. If they're there, they'll get put into the team, and sometimes it works out, and sometimes it doesn't. And it's I mean, there's plenty of training courses looking at different types of people, and It's how do you get them to work, and can you leverage what skills they've got, so they may be doing a slightly different role to what they originally envisaged they were going to do, to get the team together. I mean, there's if you read a lot of the documentation, all the HR stuff about these things, there's loads of stuff out there about how to do it, and I think people are understanding a lot better now, but it's difficult to cherry pick a team. It's very rare you start a project, you start with a blank sheet of paper, and go out and do it. I mean, you look at again the sports analogy. A manager is not doing well and he gets sacked. New manager comes in, he can't sell all 11 players in his team because they're under contract and everything else. So you effectively have to work with what you've got, work out who are the best people to keep, which ones you want to get rid of, and you might change a couple out. On projects, to a certain extent, it's a little bit similar to that. You've got to very much work with the people you've got. You have some flexibility in terms of maybe bringing some extra resources, changing how you structure things, reporting lines. Some people, some of the real technical people just want to do technical stuff. They don't really want to do any managerial stuff. They don't want to get involved in those sort of things. But if you can set yourselves up such that they can just go and do those things, that's fantastic. Other ones, some of the more managerial ones don't want to get involved in the technical stuff. They want to do the high level management presentations. They get the buzzing of doing things like that. So it's making sure that the people you've got in your team are actually making best use of their abilities.
But it would be quite hard to get the people to perform at their best all the time, though.
Yeah, it's but that's human nature. There's nobody performs at 100% all the time. So it's things ebb and flow. It's the oil industry. It's an exciting industry, but it does work 24 hours a day, and there's a lot of pressure on people. And especially doing projects, you've done a number yourself, where if you're at site, you're working 12, 15, 16 hours a day, for a few weeks at a time, and it is mentally it's very full on. People get tired, and if people got lack of sleep, a lot of pressure on them, start to get irritable, and that's when people can snap at each other. They can make mistakes and things like that. So a lot of the times, if you're a manager, you need to drive things, you need to keep the pace going, but you need to know when people are needing just to take a step back and maybe take a day off, have a bit of downtime, and then go back to it, or maybe get a bit of support or something like that. It's really all about collaboration and helping each other. You need to accept that different people need help at different times, and different people, when they get stressed out or have got issues, people react differently. Some people lash out, some people tend to go quiet, a bit more insular, which is what I would tend to do if I'm under a lot of pressure. I need to think things through, get things clear in my head before I go to the next stage. And some of the times when I've gone a bit quieter, people think then you're not interested, you're not committed, which was never the case. But it's just psychologically the way you are, and it's very, very difficult. People have got their natural way in terms of their personalities as to how they work, and it's not something you can change. You've got how you are at home and how you are at work, and you can change them to a certain extent. But when people come under pressure, they do tend to revert back to whatever their best personality is.
Okay, amazing advice. So, what is the most challenging thing about your role then?
The current project, we're under schedule constraints and we're under cost constraints, and you can't do both. If you're under schedule constraints, generally the only way you can resolve a schedule is to throw some money at it. If you're under cost constraints, then generally it's take your time, slow things down, get it right, so there's no need to repeat things or change things. So we're at the moment, the biggest challenge is trying to juggle the two conflicting priorities to try and get the job done as quickly as possible without spending excessive amounts of money on it.
But how do you do that? Because usually you're only faced with one during a project, but it's quite
well. I mean, there's multiple mini issues. So if you're doing a project, there might be like 20 components that go into the project. 20 large components in terms of for the project we're doing at the minute, separation training, you got heaters, you got compression, you got pipe work, you've got PAUs, the structures, you've got the control system, the LARs, local equipment rooms. So you've got all these little pieces that feed into the overall schedule. So it's a bit like a jigsaw puzzle. It's how do you build the jigsaw up, and working out what's the actual sequence where you can you have to do step A first, then followed by step B, then step C. Once you've got to step C, you might be able to do step F, you might be able to do step E, you might be able to do step D, and then you've got step K or whatever is afterwards. So it's working out what's the actual sequence, what do you need to do, and where have you got the influence. Some aspects of it, you might have a little bit of time on your side, so you don't need to push them too hard, you don't need to focus on them. Other ones might turn into be the critical path, which are critical for the delivery, and that's where you need to put a lot of time and effort. It's just a constant juggling in terms of managing that, just to try and keep everything moving in the right direction.
Okay, but how do you go about, if you've got like a critical path, how do you go about eliminating that? Because you'll never really eliminate it. You'll always have something critical path.
Well, there's generally 3 or 4 things you can do. You can either, do you definitely need it? If the answer is no, get rid of it, and that eliminates a problem. The chances of that happening are pretty slim to zero. So there might be an option. Do you need to, if somebody's building something, do they need to finish it themselves? Can you, take it away and ship it and install it and finish it off at the site? If there's a couple of subcomponents to it, do you need all the components? Can you, do some of them follow bits up with later? If they're buying equipment off sub-suppliers, can you do anything with the sub-suppliers to speed up their delivery? If they're doing construction activities, generally most companies will do day shift only. Can you pay overtime? Can you get them to work night shift to deliver things? If you're getting stuff shipped, it's coming from overseas on a boat, would you fly it to get it there quicker? So there's some things you can do. If it's got to go through like customs and things like that, it's coming from out with the UK. Anything you do to make sure that doesn't get delayed with the paperwork. Do you need to put your own logistics team on things to get a van or a lorry or a boat to get it shipped to wherever it needs to go. In terms of some of the testing, can you do testing at the facility before you ship it, which might save you a little bit of time once it gets to the site itself. So there's always things you're looking at. Will you give some concessions? For instance, to paint things can take 2 or 3 weeks. If you don't paint it, there's a risk associated with it, but could you install it and then paint at a later date to help mitigate against that? Insulation, some of those sort of things. If you're starting up in the summer months, you might need heat tracing immediately, whereas if it's happening in the winter months, you might need to do that. So it's just really understanding the criticality of the scope, trying to get working relationships with the vendors, really understand what their issues are, what their delays are. A lot of the orders we would place, you'd put late LDs, late delivery charges on them if they're going to miss something. And a lot of companies, if they think they're going to meet the LD or they're going to miss it, then they might slow down even more because they don't think there's any incentive. So commercially, you need to potentially be flexible with them as well. And sometimes you need to tell them, you won't charge these costs, you'll waive them if they can, if they can get close to the date that you actually want. So it's, but having good relationships with a lot of your sub-suppliers and vendors, doing vendor visits, speaking to them, finding out what their issues are. They may well be there being delayed by they're waiting for some information from somebody else who doesn't know it's a massive problem. It's amazing. A couple of phone calls, a couple of meetings, and something which looks like it's going to be a massive issue can just get resolved in an instance.
You should make it sound really easy.
It's not. But you just got to keep focused on these things, and it's just it's the small wins that lead to the big wins, because there's never one silver bullet that's going to solve everything. So it's just issues arrive, you just got to accept that, and you just got to try and manage them and deal with them at the time, and you'll get some right, you'll get some wrong, but a lot of the times not making a decision is worse than making a decision. Because if you prevaricate and just sit in some of these things, then generally the problem doesn't go away. If you make a decision, you made the wrong one. Well, that's fine. You have to rectify what your next issue was at a later date. But yeah, you do need to be prepared to go in and make some of these changes, and that's where management support is important. You need to understand what you can do and what you can't do, and having support from your contracts team, some of the other support staff that you've got, commercially as well. Some of these things, some might cost money, other ones, have got zero financial impact, but it's not one size fits all. So you do need to be quite flexible in your approach for some of these things.
I agree, actually. I do agree. So, what has been the highlight of your career then?
Um, Probably some of the startups I've done. When you take a job through from, I mean, Kraken was one where, I joined the team at the feed stage. We did it in London and then did the detail design in Kuala Lumpur. So spent quite a bit of time commuting over there. Did the construction in Singapore. Again, spent quite a bit of time. Got around to the UK, got it hooked up and, got it started up and stabilized. So it's quite exciting. So I mean that was one to be probably first startup in the Janus field. I've always got a soft spot for that one because that was the first big startup that I did. I was offshore at the time when we cracked open the chokes and got the hydrocarbons on board. Everybody on shore was celebrating, going out, congratulating themselves on what a good job they were doing, and we were still working serious hours trying to get the thing stabilized and get the rest of it online.
Okay. But that must be an amazing part of the project when you're actually there, when everything gets started up though.
Oh yeah, yeah. It's exciting because it's you spend so much time and effort getting there, and you don't know if it's actually going to work properly or not. So until you actually you can do all the simulation work, all the calculations, and think yeah it should be fine on paper, but you can start things up and you find that the fluid properties that the reservoir engineers have told you are maybe not 100% right. And things are always a little bit different. The pressures might be a little bit different. The flow rates might be a little bit higher, but lower. And it's how you manage those and mitigate any other risks. So it's flexibility and having a bit of design margin is always good. And second guessing some of the things that might go a bit awry, a bit different to what you thought. All the what ifs, and try and do some groundwork beforehand to understand what they might be and have some mitigations just sat there, so when something does happen you're not under massive pressure trying to work out what to do.
I have to ask you actually, have you ever been really nervous when working on a project that it might not start up?
Oh yeah, all the time. So we had one where again it was in Janus. We were about ready to start up and everything was checked, all good to go, and went to open the downhole valves and they wouldn't open. And there was a couple of hydraulic isolation valves which were sort of in the drawings have been left shut. So I had to get DSV back in to reopen them such that we could progress to startup. So there was a lot of frantic looking at drawings and understanding, trying to work out what had happened. And I mean, luckily there was a boat in the field that we were able to get back, which didn't delay things that much. But it's some of the jobs they've done, they would have made or broken the companies because financially they were so large and so material to what they were doing and impact on their share prices. It was the CEOs, etc., were daily updates to them as to what was happening, what you were doing, and things like that. So it's it was a lot of pressure, a lot of nervousness if if it didn't work right. But again, doing startups, you're only a part of the overall team because you're a massive design team behind it. All the other discipline engineers that were there. So it was very much a collaborative effort.
Yeah, I think so too. So I was going to ask you, does the starting up does it actually affect the share price of a company?
It would do, yeah. Yeah, well, I mean, one of the fields we started up with Kerr McGee was leading FPSO, and for a design, that was probably one of the best projects I worked on. FPSO was fantastic. Started up, it actually went pretty well, but the reservoir was an absolute dog. So production rates were just declining week on week. There was hardly any flush production at all. and the subsurface guys were, blaming the ops team. You're not doing it right, and we're saying it's not our problem. Chokes are fully open. The production rates are just not coming through, and that was one where they had to take a big impairment. Within a short period of time, Kerr-McGee got bought out by sold up to Maersk, and that was then finished. So that was, they were a relatively small company, but that was pretty much the game changer for them. So it's that's why most companies tend to. A lot of them will get 2 or 3 partners in to spread the risk. The big players like say your super majors, your BPs, your Shells, Exxons, Totals, something like that. They can afford to have some issues, whereas the smaller companies really can't. So they do like to spread the risk, and then also means you get technical peer reviews from some of your partners just to make sure you haven't missed something. So Leiden, unfortunately, was 100% Kerr-McGee. That's why they were so exposed to it.
Okay. But I think a lot of companies nowadays, they have, a lot of them have partners on big projects, usually.
Very much, very rare for any partners, for any projects now, not to have at least 1 or 2 partners. The cost of doing these projects, you're running into, if it's a brand new facility, you're running into billions of dollars to do these things. So there's very, very few companies who've got pockets that deep to go and develop them by themselves.
But even just managing that type of a project, it's huge money, isn't it? Isn't
Yeah, it's
it?
massive. I mean, you're, drilling a well, you can be 10, 20 million quid to drill a well. And if you have problems with with drilling, if you get tools getting stuck, you have to sidetrack, every day, could be $500,000 extra. So, if you go 10, 20 days over to drill a couple of wells and complete them, that's some pretty serious money. And it's the same with everything. It's just if you look at, how do you execute projects, front end loading, do a strong, front end design, try and make sure you've identified all the issues. And at least when you run into detailed design, it does minimize the risks that you're going to run up against.
Okay. And do you think about the costs when you're working on huge projects, or do you time?
Well, yeah, I mean, the costs will be whoever's a project director manages the overall cost and budget. So, it'll be split into its individual parts. So you might be responsible for a bigger part or a smaller part, depending on what you're actually doing. But with all these things, everybody's given a budget to work to, and you're expected to deliver against it. Now, if you can't do that, then either the budget was wrong initially, which may or may not be the case, or is there scope growth? Is the what you're having to deliver is a lot bigger, more complicated than what was originally envisaged? I've seen things where material wise, they think they can make things in things like carbon steel, relatively cheap materials, and then find from a materials thing there could be a risk of souring or something like that. You've got to make it out of duplex or super duplex or Inconel or something like that, and then suddenly that can add 30, 40, 50% plus to the cost of your materials, and then things can start escalating quite a lot. So and that all goes down to your front end design. You need to understand what it is you're putting in, and make sure you've got good change control as you go through.
Okay. Excellent advice, actually. So, do you have any advice for any new graduate engineers coming into the energy sector?
For new people, it would be probably just be open. Look for opportunities. Try and broaden your horizons as much as you can, and try and learn from some of the more experienced people that are there. A lot of the companies have got various documents, procedures, how to do things. A lot of those have been written based on better experiences where there's been issues, incidents, and things like that. And these procedures, documents are written to try and mitigate against those. You've got design manuals. You've got the APIs, the American stuff. You got NORSOC, the Norwegian equivalents. Use those sort of things because they do give you very good pointers as to what you need to do. There's a lot of the design manuals tell you what design margin to put in if you're designing a pump or an exchanger or a hydrocyclone or something like that. Turn down. So it's probably just try and get good understanding as to what's there. Spend time with the operations people as well. CROs, outside techs. If you're fortunate enough, you're able to go to either offshore, go to a site. Get out with the guys, spend time with them, ask them well what doesn't work well. A lot of these guys have got fantastic knowledge, and generally, if you show an interest in people and what they're doing, they'll be more than happy to help you and give you advice when you need it. So those are probably the main things.
Okay, excellent advice. So I'm going to wrap things up and maybe ask you one maybe final question.
Sure.
If you could turn back time, what piece of advice would you give your younger self?
It would probably be challenge people more. And I started supervising, managing people quite young in my career. And I was probably too soft with some people in that it didn't deliver. And I would end up some of the times covering things for them, doing some of their work when I probably should have just held into account straight away. So that's probably the one thing I would have said to myself, and delegate more as well. I find it difficult. I'm better at it now in terms of delegating to people. It's going from engineer to manager. It doesn't sound a big step, but there's quite a lot. Some of the softer issues about people management and how to get the best out of them. It's taken me a while to do that. It's if you can delegate effectively, let people get on with stuff and trust them to deliver, then I think it was one of the statements that said, the best managers are the ones that make themselves redundant because they've got nothing to do, because they've just delegated everything out to people and let them get on with it and just check in and see how they're doing. So if you can get yourself into that position, then you're doing something okay.
I think you're an amazing manager, and it's been a privilege to work with you, I tell you that. There you go. So I'm going to wrap things up. So that's all the questions I have for today. I would like to thank Alastair for your time. That brings us to the end of another episode. Thanks for listening, and see you next week. That brings us to the end of another episode. Thanks for listening. If you enjoyed the show, I'd like to gently encourage you to leave a 5-star rating wherever you listen to podcasts, and share the show with another person. You can also follow me on LinkedIn or via my website, www.michellefraserconsultancy.com. Thanks again for listening, and see you next week.